Ethan. As per request, I'm going to be doing a video on GPU pass-through for like VMs, and in this case, I'm going to be showing you the Windows VM because most people want to use these for gaming. Now, as a word of caution before getting started with this guide, I want to say that while this will provide very good performance for gaming in Windows, a lot of anti-cheat nowadays does not allow you to play their games using it. So do practice some caution and do some research before opening a game. If you think maybe something like BattleEye or Easy Anti-Cheat might not allow you to play, don't bother, it's just not worth it. You're going to have to dual boot for that or find another alternative. Anyways, with that out of the way, let's get started. This guide is going to cover Gentoo Linux specifically because Gentoo Linux has a few steps that differ from something like Arch, mostly because you have to compile stuff manually with certain flags, and you'll also need to configure your kernel a little bit differently. So, I've written a guide here a while back, I think months back, for this exact purpose, but since I guess video guide is just easier to follow, I'll start off with that. So, obviously, I'm going to read off what we are doing, or I guess you can read it yourself, but we're basically going to enable KVM, enable our motherboard's specific virtualizations like a type like AMD VI or Intel VTD, whatever, enable IOMU, isolate our GPU with the VFIO driver, install our packages for virtual machine related stuff. In this case, we're going to be using libvirt with the virt-manager, and then we're going to set up our bridged networking. So to get started with setting up KVM, KVM is quite simple to set up, especially on Gentoo. So I'm going to go ahead and head over to my kernel, and we're going to make menu config. Let me increase the font size a little bit. Okay, so here we are in our make menu config, and we need to move down to the virtualization tab, and we need to enable KVM support, compile that in of course, and KVM support for your specific processor type. Now, if you're on Intel, of course, only enable Intel, and if you're on AMD, only enable AMD. You can add these both as modules, but you can only probe one at a time, otherwise they kind of fight. Anyways, now we're going to move on to the host accelerator for virt-io.net. Now this actually changed its spot a while back, which caused me some problems. I couldn't find it, but it's actually in the device drivers section. And if we scroll around a little bit here, there's vhost drivers, and here it is. It's hiding in here, host kernel accelerator for virt-io.net, like here. So go ahead and compile that in as well, the whole section. And then we're going to go down again into device drivers, and we need to enable a couple networking options. So let's move down to network. There it is. Okay, network. So here we are in our networking, and what we need to do is we need to scroll down to, I believe we need the IPv6 protocol. You want this universal TUNTAP driver, you need this. And then I believe there's also the IPv6 protocol, which I'm not sure is 100% necessary, but as the wiki says, you should enable it. But yeah, we just need these two. We just need the core driver support and the TUNTAP, and then we can move on down to the networking options segment, which is actually out. And where is it? Networking support, networking options. And now we need to enable a couple things in here as well. In specific, we want the IPv6 protocol and 802. 80 or 802.1 blah blah blah, not this one, where is it? Here, this one, the Ethernet bridging support. We need this as well for the bridging support later, and we're going to be coming back to our kernel in just a little bit, but for now this is all you need. Go ahead and you can compile this and reboot, and then just come back when you're done with that. Alright, So you've enabled KVM, and now it's time to move on to IOMMU. So IOMMU is pretty simple to set up as well, and all you need to do is, of course, check beforehand. You shouldn't have it if you haven't manually done it, but you need to see these IOMMU groups as your end result. That's the important part. And to enable it, we need to go into our kernel again, make menu config, and in our built-in command line, if you use PCI stub like I do, or EFI stub, you need to set IOMMU equals PT, Intel or AMD underscore IOMMU equals on. And if you have this ACS override thing, I just have it here. It's actually not necessary. You don't have to bother with it. And then we're also going to go down into our device drivers. I just saw it. IOMMU hardware support. Compiled in. You need, they say to enable AMD and Intel regardless, so just go ahead and enable these options I have enabled here. Go ahead and compile your kernel, and again, come back when you're done with that. Because now we need to verify the integrity of our groups. So the script on the Arch Wiki is great for that. If you type these in, actually let me type it like this, it'll list off the group and what devices are under it. And what we're looking for specifically is the GPU that we intend to pass through and the GPU that we're using for our host. Now in my case, my host GPU is a 1060 and my guest GPU would be a 1070 Ti. And in this IOMMU group, the only two devices that exist here are the VGA controller for the graphics card and the audio device for the graphics card. If anything that is not specific to your graphics card is in this IOMMU group, you're going to have to do an ACS override patch, which is going to be available on the Gentoo wiki. I'm not covering that, but make sure to take note of these IDs right here, both of them. Keep them somewhere safe, and we'll get back to them in a little bit. So we've at this point enabled IOMMU, so we're good here. So VFIO is another kernel enabled thing, so I guess I'm gonna have to do this manually. So the next step is now going to be enabling VFIO in your kernel. And I link a wiki page here, but it seems like it's down right now, so I'm just going to show you the gist of it. So navigate in your kernel to device drivers and move down to VFIO non-privileged user space driver framework and enable this with M for module. And do the same thing for support for PCI devices and VGA devices, except VGA devices you can compile in. The reason we're compiling this as a module is because we're going to be using modprobe to kind of mess with the drivers of our NVIDIA card and our VFIO driver so we can get it to capture properly. So we're going to compile this as a module, so just do that. And then again, we're going to take those two IDs that we had earlier, so we're going to edit the file etc modprobe.d vfio.conf. If it's not here, make it. And what we need to add is options vfio-pci IDs equal, and then the two IDs that we found earlier that I told you to take note of, separated only by a single comma, no spaces. As many IDs as were in that single group, note them here, and make sure that you're doing the right GPU, because you'll lose output from that GPU. Linux will not be able to capture that GPU upon boot. It's going to be grabbed by this VFIO driver, so keep that in mind. You're not going to have it at the boot anymore. It's going to be completely taken over, so that's why you need a second GPU. Just keep that in mind. And before we can finish, we need to also we'll move down. This is all stuff that you'd need if you were using something like Grub. We're not using Grub. we're going to move down to the NVIDIA part. If you're using an NVIDIA card, which I'm going to cover in this video, you need to add a couple things to your config file. Now at the top, you need to add these 3 lines: softdep, novu, pre, vfio, regular. You need to add these 3 lines right up here. And again, they're available on this wiki, which will be linked in the description of this video. The reason we're adding these 3 lines is we're telling the NVIDIA driver, hey, before you initialize, do the VFIO one first, because that way the VFIO driver has a chance to grab those IDs that correspond to the GPU, and then the NVIDIA driver can start. So if you're using a 2-card setup, which you should be both in NVIDIA, you're going to need this. Otherwise, you're going to lose access to either both cards, or neither of them are going to be grabbed. So go ahead and reboot, and if all goes well, your video card should no longer be grabbed by Linux. It should just display nothing, output nothing, just black. And that gives us time now to set up the virtual machine. And on Gentoo, you just have to emerge QEMU, libvirt, EDK2, OVMF, and virt-manager. These are the pieces of software that we're going to be using for this specific video. And a couple notes about these packages that we're going to compile. You need to make sure that you're using the use flags for SPICE, USB, USB reader, and vhostnet. These are the important ones. You're probably also going to want Pulse and OpenGL, but the important ones for QEMU are these 4 right here. Add them to your make.conf or add them to your package.use, however you want to do that. And then down here at virt-manager, we also need the GTK use flag so we can get a graphical display. When you've got those, we can enable the service for libvirt, because libvirt is like a init system service. So we can rc update add libvirt d to default run level, and we'll add the same thing for virtlog d. And then you can also start them, or you can reboot. Regardless, add these to your init system and start them. And now we need to move on to creating a bridged network. Now I'm not going to cover this the best I possibly can in this video, because this is just kind of something that you've got to do yourself depending on how your system is configured, but I will show you the basic parts of it. So of course you're going to have to go back into your kernel, because it's Gentoo. When are you not going into your kernel? Go into networking support, networking options, and again, we've already enabled 802.1 Ethernet bridging, and we've compiled it in, and that's normal. So what we need to do now is remove our old net.whatever that we made during the Gentoo installation. So rc update del net dot, in my case it'd be enp4s0. Remove that, mine's already gone, and then remove it from your init.d directory. Right, it's already gone for me as well. And now that we've enabled this in the kernel, we can get started. So we're going to use ip-link add br0 type bridge. And this is going to create a new network interface with the type bridge on our system. And now we can ip-link set dev, which is for device, our initial interface, which for me was enp4s0, master br0, and that's going to link them. And that's what you're looking for. And I'm not going to show you my IP link because it could contain sensitive information. I'm not really sure, so just for the sake of being cautious, I'm not going to. But you should now see your devices, your BR0, your ENP4S0. And now we need to configure our net, whatever, our net device, our net config in etc conf.d net. And this can be kind of not straightforward at first, but I'll walk you through this part because it kind of takes some trial and error. So the first line should be bridge underscore br0 equals, and then your initial net interface. So enp4s0 in my case. And then if you're doing a DHCP, then you want config underscore br0 DHCP. And then you want to add these two lines, the bridge forward delay underscore br0 equals 0 and bridge underscore hello time br0. You need both of these. And that should be all for this file. And now you can link it again at cd.init.d netlo for your loopback device into your new bridge. You link those, and then you can start it as your init service, and you can add it to your default run level, and that should be all for a bridge network. Everything should work. That's how you do it with OpenRC. I can't cover the other methods with something like Network Manager because I don't use them, and it wouldn't be right for me to tell you how to do something I don't know how to do. So at this point, we've done the majority of the setup, and we can get started with actually configuring the system. But there is one final step for quality of life that I'd like to take for the sake of, I guess, usability. We're going to be using the evdev input device, which should be enabled in your kernel. I'm not sure if you have to specifically enable it, but all you need is to add yourself to the input group like this, and make sure to also add yourself to the KVM group. That's important, and the libvirt group while we're at it. Add yourself to all these groups, and then we can just list off our devices. We're listing off our input devices like our keyboards, our mice, right? You see I have my HID keyboard, my Razer Mamba, my SteelSeries, my tablet, all of this. And we need to get specific ones. So in this case, I need to get my keyboard. So I'm going to copy each of these devices, and I'm going to cat their output like this. And if I type on my keyboard and random characters come up, this is the right device. And the same can be applied to a mouse. So let me delete this and look at my mouse. In this case, it's event mouse. If I move my mouse around, you see all of this jumbled up text is coming up. If I move my mouse, that's how you know it's the right device. So play with those until you figure out which devices are right, and then note them. So in this case, I would be noting this and this. These are the two devices I'm taking note of, because we're gonna go edit a file now, libvirt.d, or not libvirt.d. We're gonna go into our qmute.conf, and we need to set a couple lines. So first of all, user equals and 1000, which is your typical user. If I type in ID right here, you can see my user ID is 1000. And then we also need to set our C group device. C group device ACL. And in here, you want to make it look like how it looks on my wiki, which is dev KVM, dev input by ID, your keyboard. This is like the whole directory to your keyboard's device, the whole directory to your mouse's device, and then these three lines down here. And that's going to be configuring all of evdev. And now, if you're on Gentoo or Arch or something like that, you also need EV tables and DNS mask-q. These are two packages that you probably want to get before trying this, because otherwise you'll have problems with the firewall within your VM and it might not start. But again, that's just a quick emerge, no configuration required. And now we can get started with the cool part, which is actually making the VM. So you can start off by opening up a virt-manager, and if all is working, then it should just pop up. There should be no devices, but it should just work. And that allows you now to start creating a VM by pressing this plus button up here. And then we're going to choose local installation medium, or media. We're going to go to our Windows 10 ISO, which is right here. You can get that from Microsoft's website. and we're going to set a couple parameters. So we're going to set the amount of RAM, which I'm going to set to a rough 16 gigs and 8 cores for CPU. And then we're going to go ahead and create our custom storage wherever you want to create it, and you just need it to be a QCOW2 disk. Don't do raw. QCOW2 just basically means that it's like dynamic, so if you make it 60 gigabytes, it's only going to take as much as it needs, which is why I'm going to make it kind of big. And then select that as your disk. That's your custom storage. And then under customize configuration before install, select it and then hit finish. And now we're going to get to the actual configuration of the virtual machine that makes it work so well. The first thing that we need to do is make sure that the Q35 chipset is enabled. This is a major part of it. And then for our firmware, we want the user share QEMU EDK2 x86-64 code. I don't use the secure code. I've not tried it, but I've had better luck with, or I've had the best luck with this. BIOS just will not work, so don't try it. It won't work for our use case, actually. Let's just be clear on that. Now we need to manually set the topology for Windows because for some reason it always uses 8 sockets and it doesn't actually work. So we're just going to put 8 cores and select the same number up here. Hit apply. And then for our boot options, we're going to put the Windows, or we're going to put the CD-ROM ISO above our hard disk. And now for our SATA disk, we're going to click on Advanced Options, and we're going to set it to a virt-IO disk. Virt-IO is going to be a major part of this, so we're going to be using it for the majority of our stuff. For our network, our NIC, we want to select our bridge network that we created up here and choose the virt-IO device model. We're going to remove this tablet and we're going to set this video to virt-IO. Actually, you can set it to QXL for now. We're going to be changing this later, but we're only going to be keeping the major stuff. So we want the AC97 audio driver because it has better performance and sound quality than the HDA ones, though it does require some configuration. And it looks good. We just need to add a couple things. So under storage, you need to add an ISO of the virt-IO Windows drivers, and I'll be showing you where you can get that. We're adding it as a CD-ROM for SATA. Now, to get the Windows, like the virt-IO drivers, you can actually get it off of the wiki. It takes you to Fedora's page, and if you scroll on down to the direct, you can get the stable drivers right here for Win10 or WinISO. Anyway, we're going to come back here. So we've configured all of this, but we're not quite done yet. We need to also set a couple things in the XML file. So first of all, we're going to set our CPU model or our CPU mode to the host pass-through for the best performance and best compatibility. So we're going to replace this CPU section here with host pass-through. And remember to set your topology accordingly, so I'm just doing 8 cores. We're disabling hypervisor because that usually causes a lot of compatibility issues with software. And we're also, if you're on AMD, we're going to add the line disable AES because AES also causes a lot of compatibility issues with software, and it's easier to disable the feature. It's like a security thing. We don't really need it. Now we're going to highlight all of this section, this Hyper-V KVM, copy it over, and we're going to replace our existing Hyper-V section, and it's going to also add a new KVM one. The reason we're doing hidden state on isn't specifically to hide it from Windows, but to hide it from our graphics card, from NVIDIA, who's going to see our virtualized system and think, no, we're not going to support it, and that's usually a big pain. So we're almost done. We now need to take this QEMU command line, set down here, add it under devices and paste it. Now what this is doing for for this QEMU command line is it's going to be adding the keyboard and mouse under evdev, and then it's going to pass through pulse audio from the VM to our host as a device. So we're using pulse audio for it in this case. I believe there's a way to do it with ALSA as well, but for now we're going to stick with pulse. Now we also need to copy this domain name up here, and we got to replace the original domain type. So we're going to replace that. This allows us to use the custom command line, and we're going to open up a terminal, and we're going to list those devices again, the keyboard, and we're going to replace keyboard name, and then we're going to copy our mouse, and we're going to replace mouse name, and apply. And that should be the configuration done with. And we're going to be passing through a GPU after we install Windows. So for now, you can go ahead and begin your installation. We're going to press any key to boot from Windows. And I guess it's having trouble finding it. Press any key. There we go. And by the way, it's captured my keyboard and mouse right now with evdev. So to get in and out, we just press both control keys. See? I'm in, out, so I'm going to full screen this now. So with evdev, we have pretty decent support already. It's not jittery. It feels pretty good. So we're going to go through the Windows installation. We're going to install. And there are some specific steps that we need to follow during the Windows installation. So we're going to say we don't have a product key. This, you can figure that out later. We're going to select our Windows type. Of course, we're going to accept their giant EULA. Actually, I don't think it's a EULA. I think it's actually like there's a different term for this kind. But at this point, it's not going to see our device driver, or it's not going to see our disk device because we chose virt-io. Virt-io is a set of devices that provides great performance, but we need to add the driver, which is why we've mounted it here. So we're going to select it. Actually, here's what we're going to do. Let's select the specific driver. So virt-io win, and then we're going to move down to VIO SCSI Win10 AMD 64 for our architecture. So we're going to select load driver, and we're going to say, yeah, go ahead and search, and it's going to find a long list of drivers. What we want is the to hide the drivers that aren't compatible, and we only want the Windows 10 driver for the virt-io SCSI controller. Gonna hit next, and it's going to go ahead and load that driver right off of the CD device that we've added for the virt-io drivers. And there it is. Our disk is now going to show up. So we're going to hit next, and it's going to install Windows. Let this installation go through, and I'll get back to you when it's done. Alright, so we've made it into Windows now. And at this point, we're going to be in kind of an interesting environment. We don't have network. We don't have a high quality display. All we have is, I guess, a okay looking VM, but we're not done quite yet. If you open up Task Manager, you'll probably see that you have your kernel, or not, what am I saying, kernel, your CPU is working, virtualization is enabled, so you can use VirtualBox. Everything is kind of intact and ready, and Windows is using 100% CPU, and that's how you know it's working, because when Windows isn't using more resources than you need, then it isn't working right. And your clock speed should be working as well. So we're going to go ahead into our, not our settings, we're going to go into Device Manager. Oh god, cannot type. Device Manager. Here we are. And there's going to be just a lot of devices with an error next to them because they don't have a driver. So we're going to click on Update Driver, browse my computer, and we're going to select under my PC the virt-io Win CD-ROM. Hit next, and it's going to search for the drivers, find the virt-io driver that you need, and then install. So go ahead and repeat this process for all of your devices. You'll see Right now it's going to identify internet and it's going to start working. Go through and do that for the rest of your devices, and I'll get back when I'm done. So you'll probably have noticed at this point in Device Manager that there was one device that we couldn't add a driver to, this multimedia audio controller, and that's why we're lacking audio. So the fix for that, which is more of like a part of my guide, is to go down, let me go to it. We need to get the Realtek audio driver, so I'm gonna have to manually type in the driver's name or the website. It's gonna take you to Realtek's website where you're gonna grab the Windows 7 Vista driver, and you're just gonna give it an email. Any email will do, just give it an email of some sort, and then do the CAPTCHA, which these ones suck. You have to do that. I thought you just had to type it in it for a while. It was annoying. Save this file to your desktop. And then unzip it. I hate how much stuff just pops up in your face. So at this point though, with the driver, we need to go to our system settings, move down to update and security, recovery, and then we're gonna do an advanced startup. And in this advanced startup, we're gonna go to troubleshoot, advanced options, startup settings, and we're going to boot into advanced startup mode. This is going to give us the opportunity to either boot into safe mode or disable driver signature checks, and that's what we're doing in this case. So we're going to press on 7 to remove the check for driver signatures, and then we're going to let it boot up like normal. Okay, so here we are booted back into Windows, so we can of course go back to our device manager, go to the multimedia audio controller, update driver, and browse for the driver. We're going to head over to our desktop, into this Windows 7, Windows blah 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 driver right here, and I believe if you just click on next, it'll find the driver manually, or rather we don't have to find it manually. And then we're going to install the driver software. It's going to give us a warning saying it isn't a signed driver, but that's fine. And now we've gotten audio, nice and latency free. I don't know if that's exactly true, but yeah, audio, it works. And I don't have audio for this recording, but yes, there is audio. Anyway, now we're going to get to the last step, which is passing through our GPU, because at this point we've done everything else. It's just time to pass through the GPU. So we're going to shut down this VM. And we're going to head back over to the virtual hardware details. And we're going to remove the video QXL and display spice. We're also going to remove serial 1, channel spice, USB redirectors, and then we're going to add new hardware, add a PCI host device, and we're looking for our GTX 1070 and its corresponding audio controller. There they are. And remember, at this point we have added this section under Hyper-V in the vendor ID state and the hidden state that will basically just ensure that our GPU works, our NVIDIA GPU works. And if you hit start on the VM, evdev is going to take over your inputs like normal. And then it's going to say that graphical console is not configured because of course we haven't set one up. We're just going to be getting output directly from our GPU to our monitor. So if you switch the input, of course I can't show you this part anymore, but if you switch the input on your monitor, you'll see Windows will boot up and then it should run like normal. But now you can use your GPU natively. So I'm gonna boot up and I'm going to confirm that everything is working. So again, you can't see this, but I'm booted into Windows. It sees my my GPU. So yeah, that's the video. That's how to set up a gaming or GPU pass-through VM on Gentoo Linux. If you enjoyed the video, let me know in the comments, and if I missed anything or could have done something better, please let me know. I hope this works for you, and I hope this video was helpful, and I'll see you next time. Have a good day. Bye-bye.